Okay, in this video we're going to look at transformations of log functions. So we need to look at this log function and get some key points on it before we can do some transformations. Okay, so if this is a to the x, this function here, this dotted function, okay, we know that a to the x, for whatever a is, goes through 1, because anything to the 0 equals 1. Okay, here's our reflection line to get the inverse, to get log, and this is log base a of x. Okay, so if we reflect that, then log always goes through the x-axis at 1. Okay, now if I go over here to, say, a units over, then I'm going to get a to the log base a of a equal to 1. The reason for that is because if I put 1 in for this, so a to the x, if I go a to the 1, I'm going to get a. Alright? So when I reflect this point here in the line y equals x, it goes right over here so that I get this point here. So that we swap the coordinates. So the coordinates of this point are going to be 1a, and so then this one would have to be a1. Okay. Now if this were 2 to the x, so if a were 2, then this point here on this one would be 1 comma 2. Okay, and this would be 2 comma 1. If it were 10 to the x, or log base 10 of x, then this would be 1 comma 10. This would go way up faster. And this would be 10 comma 1. So go way out before you go up to 1. Okay? So, key points. For transformations are going to be, well, 1, 0. Okay? And then a comma 1. That's for log base a of x. And another one, you could go over here and go back to the asymptote, and at 0, the log function doesn't exist. It doesn't exist on the whole left side here. So you cannot take the log of any negative numbers. So if I put in 0, I'm just going to put in a dash, because that represents the asymptote. Okay? So those are my key points for looking at transformations of a log function. All right, so let's look at one particular log function. Let's look at y equals, let's say, 2 times log base 2 of x minus 1 plus 3. Okay, so if I want to do transformations of this, if I look at the pointwise formula, I'm going to use these points. Or if I just look at these points and I go, okay, it's got to be vertically stretched by 2. Okay, so this point here, 1, 0, it's not going to get vertically stretched. It's on the x-axis. But a1 is now going to become a2 because it's going to be vertically stretched by 2. The y values go up to they double. And then you add 3 to it, so the whole thing's going to be moved up 3. And because it's going to be translated to the right one, the whole thing moved to the right one, and I have a new vertical asymptote at x equal to 1. Okay? So that's one way of doing it. Another way is just to do the pointwise formula. So x, y, from its parent function log base 2 of x, goes to, well, the old x's become x plus 1, because we do the opposite of what's in here. And then the y's become 2y plus 3. So if we take key points, so 1 comma, because this is log base 2, I'm going to do 1, 0, and then 2 comma 1, okay, from our key points. And then I'm going to do 0 dash for the vertical asymptote, because y can be anything, so I'm putting a dash there. Okay, plug that into the formula here, and I'm going to get 1 plus 1, which is 2. And I'm going to go 2 times 0, because the y is 0. plus 3 gives me 3. So that point is transformed to there. This point, 2 plus 1 is 3. And then 2 times 1 plus 3. So that's 2 plus 3, which is 5. And then this, well, the x is 0. So 0 plus 1 is 1. And this stays a dash. Doesn't get affected because it's a vertical asymptote. Okay? Now, if I want to graph this, well, I'm going to look at these points. Okay? So I have a vertical asymptote at x equal to 1. So I'm going to put that in. Okay? And then I'm going to plot these points. So that's 1. So at 2, 3, I'm going to go over to 2, and 1, 2, 3, plot that point. Okay, so there's 2, 3. And then at 3, 5. So there's 3, 4, 5. It's going up to there. Okay? And it has not been vertically flipped or horizontally flipped or anything, because there's no negatives on the inside or outside. And then I'm just going to fill this in to look like a log function with those key points. And the asymptote, we need to label the asymptote x equals 1. Okay? So that's one example of a transformation. Let's look at another one. How about we want to graph f of x equals negative 3 log base, let's do log base 4 of 2x minus 2. Okay, so this should be horizontally stretched by a factor of 1/2, which means it's going to get narrow. Okay, vertically stretched by 3, and vertically flipped. Okay, and then it's going to be shifted down 2. There's no horizontal translation in this, so our vertical asymptote is going to stay the y-axis. All right, so let's look at the pointwise thing here for this one. So x is going to go to 1/2 x, because we take the opposite of what's in here. And then negative 3y minus 2. Our key points are going to be 0, 1 as always. And then we've got a comma 0. Sorry, so that's not 0, 1, it's 1, 0. And then a comma 1. A in this case is 4. It's 4 comma 1. Okay. And then 0 dash. Those are our key points. Okay. Calculate new points. So 1/2 of 1 is 1/2. And negative 3 times 0 minus 2, negative 2. Okay. And then 4 times 1/2 is 2. Negative 3 times 1 is negative 3. Minus 2, negative 5. Okay. And 1/2 times 0 is 0. Like we said, the asymptote stays the same. So let's take a look at what this looks like. Okay. So the y-axis is the asymptote. Okay, so we're going to plot the point 1/2, negative 2. So I'm going to go, say there's 1, there's 1/2, negative 2. There's negative 5, which we'll need in a minute. So 1/2, negative 2, there's a point. And then I'm going to go to 2. And negative 5. Okay, so there's a point. Now, because this has been flipped vertically, it's not going to look like this anymore. It's going to look like this. So that would be our new function. Okay? Now, if there was a negative in front of that 2, then it would be flipped horizontally, so flipped in the y-axis. So it would be over here. Okay? And that's it for transformations of log functions.